we need to talk about something. This hook right here. This hook, the useEffect hook, is the most overused and incorrectly used hook in the entire React ecosystem, and no other hook even comes close. It's basically used as a catch-all or band-aid for anything that doesn't seem to fit cleanly in React. Need to fetch some data? useEffect. Need to load some props into state? useEffect. Need to sync up two pieces of state? useEffect. I'm going to come right out and make a bold statement. If you're using useEffects often, you're probably doing something wrong. Excessive useEffect addiction claims more and more victims each year, and at this point, misusing useEffects is basically a rite of passage for beginner and intermediate devs that don't know any better. But I'm going to help you break your addiction to useEffects. In this video, I'll show you all the common cases where you should not be using useEffects, which I guarantee at least one of these examples you'll have done before in your own code. And then I'll show you the actual legitimate use cases of useEffect where this hook is being used in the correct way. We're going to start off super basic and then work our way up. This first example will illustrate the most important rule on when to avoid useEffects. We have this code here that is a very basic page. We have two pieces of state, number, which is just a number, and then color, which is either a string, red, or green. In this example, let's say we want to determine the value of color depending on whatever number is. So we'll say that if number is greater than 50, then we want color to be green. If number is less than 50, we want color to be red. So we basically just have this header down here that displays the number. We have a div that is showing us whatever our color is, and then we have a button to select a new random number, 0 to 100. So we say, okay, cool. Color is dependent on whatever number is. Therefore, after we change number, we need a useEffect to update the color value. So then you end up doing something like this, where you have a useEffect in your code. So you're basically just saying, all right, anytime number changes, we're just going to run this code. We're going to say if number is greater than 50, set color to green, otherwise set it to red. Seems pretty simple and seems legit, right? If we take a look at our page here, you can see that the number is 0, therefore the color is red. If I change the number, it goes to 6.6, so it's still red. And eventually, if I click, the number will be greater than 50, so then it will turn to green. Again, every time I change the number, the color adjusts accordingly. If the number is greater than 50, it's green. If it's less than 50, it is red. So this actually works just fine. But this is breaking the most important rule with useEffects already. And that rule is, if a quote-unquote side effect can be handled declaratively, then do it declaratively without a useEffect. What I mean by this in this example is that you can set the color exactly whenever the user clicks the button. You don't need a side effect for it. Right when you click the button to set a new number, you immediately know in the code what the new number will be, so you can set the value right away. You don't need to run a useEffect that will listen for re-renders and then subsequently cause another re-render once the state changes. What I'm trying to say is you could instead do this. This implementation does the exact same thing without unnecessary complexity. Whenever we click the button, we call this handleClick function. Whenever we run handleClick, we generate a new number and store it in this new number variable. Then we set the number to this new number, and then we set the color to the appropriate color based on whatever the new number is. This is exactly what I mean by changing state declaratively instead of with a bunch of useEffects. We already have to calculate a new number anyways, so why do a useEffect after the fact to change color when we can literally just do it inside the exact same function? With this implementation, we click the button, we call this, and we calculate it all in one go. And on the very next re-render, we know that we're good to go. No extra re-renders or weird useEffects required. With the useEffect implementation, we need at least 2 re-renders and open ourselves up to problems and exponentially increasing how difficult it will be to debug. I can prove to you this works the exact same way because if I go over here and start changing the number, you can see it behaves in the exact same way it did before, in the exact way that we want it to. So it works the exact same, but this implementation is more efficient and just makes more sense. Let's move on to another example. This code right here is something you might see quite often, especially when you're constrained to just vanilla React. If you want to fetch data from an external source in one of your components, you use a useEffect with an empty dependency array. That way you fetch the data only once the page first mounts. The main thing that you usually see is a function defined inside of the useEffect like fetchData, and at the very bottom of the useEffect, we actually call that function. That way your component mounts and your data gets loaded in. Here's the problem with this. It's 2025, or maybe later depending on when you're watching this, and there is zero reason not to use a data fetching library. This way of data fetching right here is long outdated, and I promise you that the vast majority of well-built modern React apps are absolutely not doing this. So what are the alternatives to achieve this exact same behavior minus the jankiness of having a useEffect? Number one is to use a fetching library, and I would wholeheartedly suggest that you use React Query, which is now called Tanstack Query. I have a whole video on it if you've never used it before, but this library is one of the most essential libraries that I think it's important to know if you want to become a skilled React developer. Basically, without getting too far into it, it has a hook called useQuery that you can call at the top level of your component. You pass in your fetching function to it like this, and all that it does is returns you the data that you fetched and handles everything internally like loading state, error state, suspending, caching, etc. The other option that you have is using server-side rendering if you're using something like Next.js that supports that. For example, Next.js has get server-side props that you can use to fetch server-side data at request time. It'll change depending on the framework that you're using, but if you're using a server-side framework to fetch data, there's no need to have a useEffect in your component like this. So basically, there are two ways you can go to avoid this useEffect. If you're fetching data client-side, use Tanstack Query. If you're fetching data server-side, use the server-side rendering function that your framework provides, like get server-side props for Next.js. There shouldn't really be an option 3 here to use a useEffect instead. If you want to write clean React code in 2025, these are your two options. Ditch the useEffect and choose one of these. Let's move on to another example now that doesn't involve any sort of external libraries. Oftentimes, people use useEffect to compute something from state or props when it could just be handled inline or using a use memo. For example, in this code right here. All that we have on our page over here is a super basic shopping cart with apples, bananas, and oranges. In the parent component over here, app.tsx, we have all the logic and the buttons to add or remove items from our cart. So you can see here we have a button for removing apples. This would add an apple. And we do that for each possible item. Most of this code, however, isn't really super important for this example. What's important is that we're rendering this store card down here that passes in items. And store card is this component you're seeing at the bottom that contains the total price. All the items is just an object that contains the count of how many of each type of item that we have. So we are passing that down to this store card. Now if we go over here to our store card component, here's how this is commonly handled. We have our total price as a useState, and we know that any time that items changes, price needs to change as well. So we have a useEffect in the child that sets the price depending on whatever items is. So we take the number of apples that we have times however much an apple costs, which is just in this price map right here. We assume apples cost $2.50, bananas cost $1.50, and oranges cost $2. So we say number of apples times the price of apples, and we do that for each different fruit, and that's how we set our price. We know that the price needs to derive itself from whatever the items is, so it makes sense we do a useEffect, right? Well, if we look over here, this works perfectly fine. I can change how many apples we have, and you can see the total price adjust. Same with bananas, same with oranges. I can add or remove as many as I want, and the price in this child right here is always going to adjust because of this useEffect. Each time items changes, meaning each time we add or remove an item, we're going to recompute this price because this useEffect will force this code to run. Here's the problem though. This useEffect is completely and totally unnecessary. Why use it if we don't even need it at all? We don't even need this price value to actually be stateful, meaning with the useState. So we could literally just make a new variable right here. Let's just delete this. We could say const price and set it equal to this exact same logic right here. And then just delete our useEffect entirely. And now our component would behave in the exact same way. If I go over here and start adding and removing things, you can see it adjusts in the exact same way it just was without the unnecessary useEffect. This is a pretty common pitfall and misconception on when we need to actually use useEffects. Generally, when we have derived values, meaning something like price, that is always going to be derived from whatever items is, we can literally just calculate this in the body of the component with zero problems. Each time items changes, items is a prop, so it's going to cause store card to re-render, which means this code right here is going to rerun anyways. Having a useEffect here is just completely unnecessary because we can always derive this price directly from items right in our function body. Now something to watch out for is if you have a derived value like this and you don't want to run this calculation on every single re-render unless you have to. That's where useMemo would come in. In this case, that would just look something like this. Items is the only possible thing that could actually cause a re-render for this whole component, so using a memo is kind of redundant in this case, but in general a use memo is what you would typically want here for a derived value if you wanted to recompute it whenever items changes. Again, a quick sanity check: if we go over to our page and start adjusting the items we have in our cart, you can see it works in the exact way that we want it to, no use effect required. Basically what I am trying to show you with this example is that oftentimes people will use a combination of useState plus useEffect when trying to calculate some derived value like price. However, there are many times where this derived value can just be computed directly in the component body or with a use memo and can replace useState and useEffect entirely. So if you're constantly pairing useState and use memo together, I would say there's a very good chance that you could just replace it with a use memo, or even just without a memo, just compute it directly, and you're simply overthinking it. If this price right here has to be stateful, like you need to call setPrice as a useState in this child for whatever reason, then you still don't need a useEffect. You could just lift price and setPrice up to the parent and pass those two as props down to this child. And then in the parent, you could just compute price each time one of these buttons is clicked. So if it looks like you're backing yourself into a corner and forcing yourself to use useEffect, you're probably doing something wrong, and there's almost always another way. There's a couple more common misuses of useEffect, but instead of taking an hour to go over all of them, I want to now show you examples of when having a useEffect is actually necessary. That way you have a better idea of pretty much the only cases where you should actually be using this hook. The first case where having a useEffect is completely valid is when you have a global event listener that is tied to React state in some way. Take a look at this code here. We have a useEffect that defines this handle key down function that basically just sets this piece of state every time we type something on our keyboard. We create the event listener in the useEffect, and during the cleanup, we remove the event listener. The main idea here is we can go over to our app and we can start typing, and the text just shows up on the page without having an explicit input field. Because I have an event listener, I'm able to just type stuff onto the page. Think of a typing game like Wordle, where you can just start typing on your keyboard and the letters start to fill in. That's the kind of use case that we're talking about right here. Whether it's key down or certain click events that need to be mounted on the window, this is the standard way of doing event listeners in React. A useEffect with no dependencies that will run once the component mounts, mounting this event listener on the window so that we can use it. There are libraries that have this kind of logic encapsulated in more convenient hooks, so you don't always have to do this, but this is absolutely an acceptable use case for a useEffect. I want to mention, however, that you should still be smart about how you handle your event listeners so that you don't need a bunch of effects and don't need to mount a ton of event listeners on your window. Remember that most JSX elements have built-in support for events. If I make a div down here, you're used to seeing stuff like onClick. There's also events for a bunch of other stuff too. Like you can actually do on key down on certain elements, you can do on mouse up, you can do on mouse down, and the list goes on and on. Remember the rule about useEffects. If it can be handled declaratively in the event itself, do that. So if you can use one of these built-in JSX event listeners, you should always do that first. Only if you need the event listener on the window or handled globally in some way should you really be using a useEffect. But again, if you do need to do this, this use case for useEffect is completely valid. Let's move on to yet another example where useEffect can actually be used correctly. One of the more common use cases of useEffect is measuring elements using refs, or doing anything that involves direct interaction with DOM elements. For example, in this code here, let's say that for whatever reason, we need to know the width of this div right here. So we have this div ref slapped onto it, which we just instantiate up here. Obviously, in this case, this width right here is completely hard-coded, so technically we know what it is, but let's imagine a scenario where we maybe have images or elements coming from outside, and we have no knowledge of what the width is prior, which is why we need to know the width of this div. So how you typically get the size of an element in React is take whatever ref you have and call getBoundingClientRect on it, and then you can just access properties like width and height from that. So right now in our code, that's all we're doing. We're just getting the getBoundingClientRect, and then we're logging out the width right here. This, however, is actually a problem and is not going to work. Because if I go over here to our DevTools and we look in our console, you can see right here where we're logging out the width, it says width is undefined. And this has to do with the order that React does things. So we're going to get down with some nitty-gritty details about React for just a second. Whenever this component mounts for the very first time, this code that you're seeing right here is going to evaluate before any of the JSX evaluates. So what does that mean? What that means is that this code, where we're getting the boundedClientRect, is going to run before the ref is even attached to this div, which means that this div ref is not even going to actually be defined the first time that we run this code right here. Hence why it's telling us that width is undefined, because the ref itself hasn't even had time to mount yet. However, let's actually take this code right here, this useEffect. Let's uncomment it. Let's remove the code right here, import useEffect from React, and let's see how this changes. If I go ahead and save this code right here, and it reloads, you can see now we have in our console, it's saying width is 192. Just to double check, we can refresh and look at it again, and you can see it indeed says that width is 192. So now the width is defined, but before it was completely undefined. Why does this happen, and why is useEffect the solution for this? Just like before, it has to do with the order in which React does things. Effects in React are run after the DOM updates. In our case, what that means is that when the component mounts for the very first time, all this code is technically going to run, then the JSX is going to get rendered in the DOM, and then only after that do we actually run the effect. So even though when it first mounts we actually see this effect, we're not running this until we're certain that these elements have actually been computed in the DOM. So again, the function body runs first, and then the elements get rendered in the DOM, and then only after that do effects run, because they have the lowest priority. The reason why that's going to work in our case is that means that this divref is going to be defined by the time the useEffect runs. This goes first, then the useEffect runs, so by the time that we get in here, divref is going to be defined, which is why calling getBoundingClientRect and getting the width is giving us an actual number and not just giving us undefined. So it's all about timing and the order in which React does things. What this means from a broad general perspective is that you can pretty much be guaranteed that by the time a useEffect runs, the DOM is going to be ready to go. So if you need to manipulate anything in the DOM or get any information from the DOM, like the size of an element, for example, you can do that using a useEffect. Because if you don't use a useEffect, it's going to be undefined right when the code first runs. So this use case right here with this code is a completely valid use case for useEffect. Usually if you're doing something like measuring an element, you'd want to use something like use layout effect instead of useEffect, but that's a subtle difference for another video. Let's go to another example that uses very similar logic. In addition to interacting with the ref right on component mount, you might find other scenarios where you need to do something right when the component first mounts and only then. An example could be this code right here. So let's say our parent component, this app component, for whatever reason, needs to know exactly when its child, this random component, is actually mounted. In this example, we just have a function called handleChildMounting that just logs out that the child has been mounted. And then we pass it down to random component, which again is the child. In random component, the only real way to guarantee that this component is actually mounted is to run something in a useEffect, like how we're running the onMount prop right here. This is again the same logic that we just went over a moment ago. Since effects fire after the DOM is rendered, a useEffect with no dependency array, just like this one, would technically be the correct spot to put code where you want it to be sure that the component is actually rendered and mounted. If I were to ignore this and I were just to try to call onMount in the component body like this, not only would this get called every single re-render that happens in this component, but we can't even be sure in the first render that it would be correct. Because since the function body runs before anything is put into the DOM, we'd just be optimistically guessing that the component will mount just fine. By using a useEffect, just like this here, we can be sure that the child is actually mounted and calling this onMount function at the proper time. Because again, since effects fire after it's in the DOM, we know once this code runs inside here that the component has mounted. I actually had a legitimate use case for this recently. A parent component could render multiple different children, and each time a child mounted, I needed to fire a function in the parent, kind of like this one here. So I did something just like this, where I pass an onMount prop to the child, and I just called it in a useEffect with an empty dependency array. That way I know if this function gets called, that the component is mounted and ready to go. So basically what I'm trying to get at with this example and the previous example is that you can use useEffect if you need to do something or need to know exactly when the component is mounted. So whether it's getting some information from a ref that's attached to an element, or firing a callback function once the child mounts, these are valid use cases for useEffect, doing something on the initial mount, and only then. Let's now move on to the last example. And this is a big one because it's probably the broadest useEffect rule. Let's go back to our event listener example for a second, where we were creating an event listener for the keydown event. The reason why we needed a useEffect in this case, like we have right here, was because ultimately event listeners sort of live outside of the React lifecycle. They mount on the window themselves, and React really has no context to them actually existing. So the next valid use case of useEffect, which again is very broad, is when you're dealing with anything that exists outside of React. And this could mean a lot of things, so I can't exactly give an exhaustive list, but this can mean things like in native JavaScript like event listeners or even accessing local storage. Or it can mean external libraries like graphing or charting libraries or even socket servers. Essentially anything that is external to the React system. Let's go over an example to show you what I mean. This example might seem like a bit overkill, but I want to show you exactly what I mean. I've just installed a charting library called chart.js. The problem is chart.js is not a React library. It is a JavaScript library. Just because it's a JavaScript library and not React does not mean that we can't use it in React, however. So if we want to use a straight JavaScript library, we need to find a way to sync it up with React if we want to use it correctly. That's all that the code you're seeing right now is actually doing. If we go down to our JSX here, you can see that we have this canvas that has a canvas ref attached to it. I define that canvas ref up here. And then at the bottom, we have our mock chart data, which we can assume for the sake of this example is tied to React in some way, shape, or form. Because chart.js is dealing with straight JavaScript and lives outside of the React world, that means a useEffect would actually be appropriate to sync these two things up. Let me explain. This useEffect looks like a lot, but all it's essentially doing is rendering out the chart in React land. It does that by first destroying the existing chart if it does exist. And then we have this configuration object where we basically just say what we want the chart to look like. This is library specific, so we're just saying we want this kind of stuff to be on the chart. And then we just create a new chart at the bottom and we store that in our chart ref. And doing this kind of thing is only really possible inside of a useEffect. Why is that? Well, because again, refs, like we're using them here, are basically like React's gateway to the outside world. So anything involving the browser typically, or external libraries that use vanilla JavaScript. And just like I showed you before, if we try and manipulate and access ref values, like canvas ref or chart ref, outside of a useEffect, then on the first render, we cannot guarantee that they will be defined. And in fact, if you don't use a useEffect, they can cause problems. By using a ref to attach itself to charting code that lives outside of React land, and then creating a useEffect like this, we can now manipulate that ref as if it were part of React. And now if we had any sort of state or anything in this component that was native to React, we could have it interact with this chart in this useEffect, which again is effectively syncing up React with stuff outside of the React world. This is one of the most common and most broad but genuine use cases of useEffect. If you're dealing with anything that lives outside of React and you need to sync it up with React, a useEffect is typically necessary. And I want to again reiterate that this is not just charting libraries or external JavaScript libraries. This could be anything external, from event listeners to socket servers, or just broadly anything that isn't React specific. The very last thing that I'll go over very, very briefly on when you can use effects is if you need anything that requires a cleanup. One thing that useEffects are very good for is removing things that were maybe added to the browser that aren't handled by React automatically. So earlier I showed you the example of the event listener, and in the return of the useEffect, we were removing the event listener from the window. Because again, remember that the return function for a useEffect is going to run once the component unmounts. So if in the useEffect we're doing something like setting an interval, that interval is actually going to mount in the window itself. So once this component unmounts without doing something like this in a useEffect, we could possibly run into memory leaks. Because once the component unmounts, we're not actually taking that off the window. It's still sitting there. So again, this could be event listeners that need to be cleaned up once the component unmounts, or intervals, or you can do timeouts with set timeout. Those all kind of fall into the same category of things that need to be cleaned up once the component unmounts. If something needs to be cleaned up when the component unmounts, but is not handled natively by React, a useEffect with the return is generally a good idea. And this again reiterates the point that useEffects can be effective for things that exist outside of React. Because again, when you're doing things like event listeners or intervals or timeouts, those things exist in the browser. They're not actually inside of the React state system itself, so cleaning up via useEffect can be a very valid use case. And with that, we're going to wrap up this video. Hopefully after watching this video, I've given you the confidence to clean up your code and not spam useEffects everywhere. After all, they make debugging significantly harder and are this weird band-aid and catch-all solution that can usually be avoided, minus the few examples I gave here at the end. Now that you know how to avoid useEffect when necessary, I'm confident that you'll be far better as a React developer. Take care everyone, and I'll see you in the next one.